Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, let us discuss the concept of equilibrium of coplanar forces. As you know that here the coplanar forces means all the forces are lying in a single plane and may be acting at different locations of the body is said to be coplanar forces. And what is meant by equilibrium? Let us understand the concept of equilibrium as it is, the definition is given. Let us look at this. A body is said to be in equilibrium under the action of the forces when either the body is at rest position or it may be moving with uniform velocity. So, the body is rest position, that means the resultant is 0. The moment you say that it is R is equals to 0, the resultant is 0 means the body is at rest position. Or so this is possible as you know that R is equals to mass into acceleration ma. So, this is equals to 0. This is only possible when acceleration is 0. Mass cannot be 0 and only the acceleration is 0. So, acceleration is 0 in two conditions, either the body may be at rest position, it is not at all moving, then the acceleration is 0, or the body may be moving with uniform velocity, constant velocity. So, uniform velocity. So, then also it is 0. So, this is the mathematical definition of mathematically you can define like this. The resultant is 0, means it is either at rest position or it may be moving with uniform velocity. And graphically, let us consider the forces, system of forces acting on the body. If we join all the forces by tip to tail method or in order, it is going to form a closure polygon. So, let us consider a particle and F1, F2, maybe F3 or the forces acting on a particle. And if we join all these forces by tip to tail method, let us consider F1 by magnitude and direction. F1 is acting to the right and F2 the inclination is known, and F3 the magnitude and inclination is known. It is going to form a closed polygon by virtue of their magnitude and directions. That is what is exactly graphically you can state that it is going to form a closed polygon, then the resultant is 0, and that resultant is 0 means that it is equilibriant is 0. And let us look at this. You have as you know that the coplanar forces, again you have coplanar concurrent forces as well as coplanar non-concurrent forces. That means all the forces are lying in a single plane and all are meeting at a point. That means this is what exactly the diagram. So, this is similar to the analysis of the particle. It is the hypothetically the body, the rigid body is reduced to a particle, whereas the other side you have a body and forces are acting at different locations, F1 at point A, maybe F2 at point B, and maybe F3 at different locations of the body. So, this constitutes coplanar non-concurrent forces. This means it is a rigid body. It is a rigid body, the concept of rigid body. And here the moment you say that R is equals to 0 in coplanar concurrent forces, we know that it is R is equals to, it is sigma Fx square plus sigma Fy square. The moment it is R is 0, obviously sigma Fx is equals to 0, equation 1, and sigma Fy also 0, this is equation 2. That means you have two equations of equilibrium. These two are called equations of equilibrium, which is also known as condition for the equilibrium. And when you have two equations, you can solve for maximum of two unknowns only. Let us assume that if you have more than two unknowns in coplanar concurrent forces, then the system is said to be statically indeterminate system. Let us consider an example. Here weight is acting downwards and it is connected by three cables. I am considering three. In this you have tension 1 T1, tension 2 and tension 3. So let us assume that it is alpha and this angle is beta. Let us say that T1, T2, T3, three unknowns. So you have only two equations. So this particular system is statically indeterminate. You are unable to solve these three unknowns just by using equations of equilibrium. What is that it is required is these problems will be solving in strength of materials by considering the geometry of the deformation, which is also known as a compatibility equation. We call it as compatibility equation. So equations of equilibrium plus compatibility equations, so that you will be able to solve the statically indeterminate problem or system. The other side, let us look at this coplanar non-concurrent forces. The moment you say that resultant is 0 means it is sigma fx is equal to 0, this is equation 1, and sigma fy also 0, and the third equation is because it is subjected to turning effect, and that is sigma moment about any point on the body is also 0. So let us look at carefully. You have 1, 2, 3, three equations of equilibrium. So these three are called conditions for the equilibrium or equations of equilibrium, and you will be able to determine three unknowns using these three equations. Let us assume that you have, if it is more than three unknowns, then the system is called statically indeterminate system. Let us consider an example, a truss. Let us consider a truss. You have like this. Let us consider a truss is all these are joined by pin joints, and at this you have a hinge. At other end, let us assume that you have a roller support. Both are hinge connected. Let us assume that you have A and B are the hinges, and let us consider it is subjected to external loading P, Q, and let us say it is S. P, Q, S are the external forces, and as you know that hinge connection always you are going to replace with one horizontal, let us say RA horizontal and RA vertical. Here you have two unknowns, and the other side, let us look at that, you have another set of two unknowns, that is RB vertical, and to the right it is RB horizontal. So RB horizontal and RB vertical, 2 plus 2, 4 unknowns, but whereas you have three equations only. So this particular system or this particular problem is called statically indeterminate problem, indeterminate. So you are unable to solve these particular problems just by using equations of equilibrium. What that it is required is, again you need to have the geometry of the deformations or compatibility equations. So equations of equilibrium plus compatibility equations. Compatibility equations you are going to get from the geometry of the deformation, and you will be able to solve this particular problem in strength of materials. So this is coplanar concurrent forces. The ideologically you can call it as a particle. You have two conditions or two equations of equilibrium, whereas the other side coplanar non-concurrent forces, which is treated as a rigid body. In rigid body, the forces are acting at different locations of the body, but all are lying in a single plane, and you have three equations of equilibrium. Sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. You have three equations, and you are able to solve three unknowns. If the unknowns are more than three, like this in this particular system, so you have 1, 2, 3, 4, 4 unknowns. These 4 unknowns you cannot solve just by using three equations of equilibrium. You need to have other equations. That equation is called compatibility equation, and this equation you are going to get from the strength of materials concept, that is geometry of the deformation, so that you can solve for the unknown forces. Thank you for watching this video.